We're going to pick up our differential analysis discussion here with do we replace a piece of equipment or with something newer, or do we continue to use it? A newer piece of equipment might cost us more money, but it may be more efficient and ultimately make more money for us in the process. So this is a great place to utilize that differential analysis. Once again, just like with the leasing versus selling example, we're not going to take into account the sunk cost of what we paid for the equipment because it's already done. We're only looking at the incremental difference in those alternatives going forward. So here is our old machine and the analysis of that, and we've got the purchase price of the new machine, $250,000, and we think that there's going to be estimated variable costs of $150,000, both with a 5-year life. We think we can get $25,000 for the one that we currently have if we were to then sell it, and we've got manufacturing costs appreciably more for the old machine. It's costing us a lot more to run that than a spiffy, new, modern, and efficient one would. So what are we going to do? Well, we're going to set up 3 columns. Alternative 1 is we keep using the old machine. Alternative 2 is we replace the old machine and get ourselves a new one. So if we keep using the old machine, we're obviously not going to sell it, so we're not going to have any proceeds from selling that. We're not going to spend any money buying a new machine. And over the 5 years that we'll continue to use that, we're going to have variable manufacturing costs of over $1 million. Now let's look at what happens if we replace the old machine. Well, we're going to get $25,000 from selling the old machine. We're going to spend $250,000 on a new one, and the variable manufacturing costs are only going to be $750,000 with the new machine because it's going to operate so much more efficiently. And we can see that the differential effect of choosing alternative 2 is a positive $150,000. And so this, despite the pretty substantial cash outlay for the new machine, this is a far more advantageous way to go than to continue with the old machine. Now, sometimes there is a factor known as opportunity cost, which occurs because we can't necessarily choose all of the alternatives. We have to give something up sometimes in the course of making a choice, as opposed to saying, well, we'll choose both. Well, so we don't always record the impact of the lost opportunity cost, but we don't want to lose sight of it either. So just also keep in mind, what is it that you may be giving up by choosing one course of action over another. In terms of processing or selling an item, this is also an area where you can employ the differential analysis. Sometimes you will have a product which can be sold in a current state or with minimal processing, or you could process it further and sell it as an entirely different product. Different from the example we'll talk about, but I think about it in terms of dairy. You can sell milk, or you can process that further and you can have cheese, cream, whatever dairy products can be made from that. And as a distributor of dairy product or manufacturer of dairy products, you've got to conduct this analysis. Do we just sell milk? Is that the most profitable way for us to operate? We don't incur all those additional processing costs. On the other hand, we probably can't sell milk for as much as we can sell some of the other items. So, and is there a certain mix where we can maximize profits by selling some of each? And So in this example, we're going to talk about kerosene and processing that further. And I know virtually nothing about kerosene and only slightly more about dairy products, which is why I used the dairy example. But apparently, if you process kerosene further, you can get gasoline from it, or so the slide tells me. So we've got a batch size of kerosene of 4,000 gallons, and it costs us 2,400 per batch to produce the 4,000 gallons, and we can sell them for $2.50 a gallon. Now, if we were to process it further into gasoline, the same 4,000, we assume that there's going to be some evaporation and that it's going to only yield us 3,200 gallons. And then we've got to take into account the cost of the conversion of that into gasoline at $3,050 per batch. And so we can sell that for $3.50 a gallon. Well, what makes more sense? And we set up our 3-column format and we look at, okay, are we going to sell kerosene or are we going to process it into gasoline? And here it's we've got the revenue per batch, and down here is how that is calculated. I won't go into that, but we see that we've got a profit associated with kerosene of 7,600 and gasoline of 8,150. Now, the differential effect, we are better off by $550 per batch by processing it into gasoline as opposed to just selling it as kerosene. Let's say a customer comes in. We manufacture a pretty standard product, but customer comes in and says, I need this special order item. I am willing to pay X amount of dollars for it. You might have to either have people work overtime or stop making some of your other product in order to be able to accommodate this special order. So you're going to, you might say to yourself, well, okay, if we don't have excess capacity in our factory, or even if we do, what is the differential impact of accepting this order? So we've got the B-Ball Incorporated, and they manufacture basketballs. They can manufacture 12,500 basketballs a month, and they sell about 10,000 a month for about $30 a basketball. You can see the fixed and variable costs there for a total of $20 in costs per basketball. So they get an offer for 5,000 basketballs at 18,000 each, and they can spread those over 3 months. And because they have some additional capacity, they're not operating at their maximum capacity. And they can, again, if this were something they had to do in 1 month, that might be a different, well, it would be a different analysis, and maybe they couldn't use their excess capacity to satisfy that order, but they're going to be able to spread it out over 3 months and not have to have any overtime costs as a result of that. And they won't have to change anything about their current domestic market. So do they reject the alternative order or do they accept the alternative order? If they reject it, obviously we get no revenue from it, we have no variable costs and no profit. If we accept the order, then we've got 90,000 in revenue, 62,500 in costs, and we get a $27,500 benefit from accepting alternative 2. And despite the fact that this special order of $18 is going to be less than what we would normally sell these basketballs for, it's not going to impact our $20 per basketball business, so we can continue to do that. If it were, obviously that's going to be a whole other issue. also consider the scenario where we are operating at capacity, and instead of $18 a basketball, maybe this special order is going to make us $30 a basketball. So now we've got to say to ourselves, okay, do we cut back on some of our existing business, or do we add a third shift, or do whatever to accommodate this order? So you can use this analysis along those lines as well. And so I am not going to do the checkup corner with you. You can pause the slide and review this. And I'm going to stop here and hop over to the next video.